Section 5.2, we're going to talk about functions. A relation or relationship is any set of ordered pairs. What are ordered pairs again?
Points on a graph.
0, comma.
They could be points on a graph. They could be like 0, 1. There's an ordered pair. Why is it called an ordered pair?
It's in order. That's why.
There's two of them. Pair. And order makes a difference. 0, 1 and 1, 0 are different things, aren't they? Mm-hmm. To be an ordered pair, does it have to be numbers? No, usually in a math class we use numbers, but it doesn't have to be numbers. So, well, I'm just going to write down some more things here. 1, 5, and -2, 7, and 3, -6. There's a relation. A relationship is just a whole bunch of ordered pairs. There's a whole bunch of ordered pairs. A function, on the other hand, is a relationship. In other words, it's a bunch of ordered pairs where each input is usually the x value, has exactly one output. Output's usually the y value. So the relation I wrote up above, is that relation a function?
Yeah.
50-50 chance of being right.
Yeah.
Some say yes, some say no.
I think it is because if input X has one output Y. So I think maybe.
I think it's not a function. I think there's one input for X that has more than one output. Which X number has more than one output?
How the last one?
-2.
No, -2 only has one output.
1.
1 has two outputs, doesn't it? If X is 1, Y could be 0. Or, over here it says if X is 1, Y could be 5. So the input 1 does not have exactly one output. It has two outputs. When X is 1, Y could be two different numbers. If X is 1, Y could be 0. If X is 1, Y could be 5. 1 has two outputs. So is this a function? No, this is not a function. All right, I'm going to make up some other functions. My inputs are going to be people, and output is going to be age. So, for example, I might put my son Blake right there. If I were to ask Blake, how old are you, what's he going to tell me? How many answers is he going to give me? 1. If I were to ask him that, he would tell me he's 18. If I were to put my other son, and I asked him, how old are you? How many answers is he going to give me? 1. Would he ever give me 2 answers?
One might smack you first for not remembering, then he might tell you. But
He might smack me first if I don't remember how old he is. That's true. And he's almost as big as I am, so that could be trouble. But is there going to be an answer?
Yes.
Yes, there will be exactly how many answers?
1.
1. There will be exactly one answer. He would tell me he's 15. I might put myself down. And if you were to ask me how old I am, what would I tell you?
You might give us 2.
22.
I might tell you 22. I didn't say I was going to tell you the truth, but how many answers would I give you?
1.
I would give you exactly one answer. Is this a function?
Yes.
Yes. Because if you ask somebody how old they are, what are you going to get? You're going to get exactly one answer. So this is a function. All right, so here's another relation. Still going to use person. And I'm going to use siblings. Is this a function?
No.
No, why not?
More than one.
People could have more than one. For example, if I were to put myself here, I happen to have two sisters. So there would be one input, me, that has two outputs. So is that a function? No, that's not. This could also happen. I have a friend whose name is Nora. Nora is an only child. So what would Nora list for her siblings? She wouldn't have any. So this is not a function for two reasons. It's not a function because some people can have more than one sibling. It's also not a function because you can have some people who don't have any siblings at all, so they can't put anything there. So this one is not a function. Not a function. All right, well now most of the functions we're going to deal with, or most of the relations that we're going to deal with in this class, are going to have numbers. We're going to have x and y. So I'm going to make up some numbers for x. I'm just randomly writing numbers down here. 3, 2, 0, 2, 5. And then I'm going to write some numbers for y. 1, -6, 3, 4, and -2. So I just threw down some random numbers there. Nothing particularly important about those numbers. Is that relation a function?
No.
No, why not?
Because 2 has 2 outputs.
X equals 2 has two outputs. Not a function.
Would you want us to circle with that, or would that be?
I would want you more to write not a function because x equals 2 has two outputs. I just circled them to emphasize it. Okay. How about this one? X, Y. X is going to be 1, 2, 3, 4. Not so random that time, right? My Y numbers are going to be 0, 5, 1, and 0. Is that a function? Yes or no?
Yes.
Yes? Even though the 0 repeats?
Yep. Because that's the output. It has a different input.
Correct. The rule is every input has to have one output. Was there a rule that said outputs can't have more than one input? No. The rule was every x has to have exactly one y number. Does every x have exactly one y? Yeah, it's okay that y numbers repeat. It's not okay when x numbers repeat. So yes, this is a function. Questions on that? Okay, so question 1 says, some ordered pairs of 4 relations are listed in the table below. Which of these relations could be functions? Explain.
3 and 4.
And which could be linear functions? All right, so before I could read part 2, you told me that 3 and 4 are functions.
Because each input has one output.
Because each input has one output. I think I agree with you. What's wrong with relation number 1?
3.
Okay, so number 1, no. X equals 3 repeats. What's wrong with number 2?
They're all 5.
They're all 5. 5 repeats over and over and over again, doesn't it? 5 has 5 different outputs. That's no good. So number 2 would be no. X equals 5 repeats. But 3 and 4 are okay. Why are 3 and 4 okay?
Yeah,
X
so,
didn't have, I thought X could change, but Y couldn't. So Y is, the first one's not okay.
The first is not okay because,
I thought X didn't matter.
I thought that was a
no, what,
function.
no, to be a function, X cannot repeat. So for example, this one we had back here, X repeated. So this one was not a function.
Oh, I just wrote it down wrong.
On this one, Y repeated. It's okay if Y repeats.
I just wrote it down.
Oh, okay. So to be a function, your X's cannot repeat. So on number 1, X equals 3 repeats, so that's no good. Not a function. Number 2, X equals 5 repeats. It repeats a lot, doesn't it? So that one's no good. Number 3, I think is okay. Relation number 3 is okay because the X's are 0, 1, 2, 3, 4. No X number repeats at all. And number 4 is also okay. The X's go 3, 4, 5, 6, 7. None of the X values are repeating. So my answer would be number 3 and 4 are functions. No X value repeats. Questions on that? Okay, so 3 and 4 are our functions, and then it says which of these could be linear functions?
Just 3, right?
Just 3. Why is 4 not a function?
Because the y values don't increase the same amount.
The y values do not increase the same amount. So the x values are always increasing by 1, but here the y value increases by 2, then it increases by, I think that's 4,
Or my bad, 4.
then 8, then 15. So why does that make it not a line?
Because you'd have
Because
to
it has to
move,
increase at equal intervals.
yeah, you have to move your line a little bit.
Correct. Well, what would have to happen here? Here we go up to the x's, the y's go up to, but the y's. Gotta say this right. The y values go up to when the x values change by how much? So right there, my slope would be 2, wouldn't it? But if I go to the next spot, my y's go up by 4, but my x's only go up by, so that would be a slope of 4. So that's not a line, is it? To be a line, the slope always has to be the same. So number 4 is not a line. The slope is not always the same. But I think number 3 is a line because each time the x value goes up by exactly 1, the y value goes down by exactly 5. So number 3. In fact, we could say the slope is, what's the slope?
5, right?
Not 5, but you're very close.
1 was 5.
It's going down. The y values are going down.
-5.
So the slope is -5. And I'm going to put it as -5 over 1 to even emphasize that my y's go down by 5 when my x's go up by 1. So my slope is -5. Questions on that? All right, number 2. We have 4 pictures.
Can I see that real quick one more time?
Yep. That good? All right, -2. Or number 2. We have 4 pictures. And it says, determine whether the graph represents a function. In other words, some of those things are supposed to be functions and some of them are not. How can you tell?
It's a 1.
If it's a line, so you're saying B is a function? Maybe. Maybe is a correct answer. Could you be more specific?
Yes, it's,
B is a function. Why?
there's only one output for each x.
All right, so if I told you, unfortunately there's no scaling on this graph, but if I told you x is 0, you would tell me y is
3.
maybe 3. And if I told you x is 5, you would tell me y is 3. No matter what x number I pick, how many y numbers are you going to give me? 1. So I agree. This is a function. No matter what x number I pick, you're only going to give me one y number. How about the first one? Function, yes or no?
No.
No? Why not? What's wrong with it?
That's crazy.
Because it is kind of crazy.
Squiggly.
It just because it's kind of crazy doesn't mean it's not a function.
Because when you go to x, you could either go up or down, and it would, like, you'd have 2 y's for 1 x.
Where?
Where it's like zigzags.
Right where it zigzags. So, for example, if I were to pick this x number right here, I'll pick that one. How many y numbers are there?
2.
Oh, I think there's even 3
All right.
for where I picked mine.
4.
You're right. Because if I pick this x number, I could use that y value, I could use that y value, or I could use that y value, couldn't I? So is that one a function? No, not a function. All right, so I'm going to draw a special kind of line here. I'm going to draw this line. What kind of line is that?
Nonlinear?
A nonlinear line? That's an oxymoron. What do we call a line that goes straight up and down?
Vertical?
Call it vertical.
At B.
What's that?
Oh, I was starting because you drew that straight up.
Oh, it looks a lot like D. I agree. It looks a lot like D. But this is a vertical line. And notice that this vertical line crossed the graph more than one time. What happens on this one that is a function? If I draw a vertical line, no matter where I draw it, let's say I draw it over here, how many times does that vertical line hit the graph? Exactly once. What if I had drawn it over here? How many times would it hit the graph? What if I drew it in the middle? Once. All right, so there's a rule, and it's called the vertical line test. And the vertical line test says, if I can draw a vertical line and it hits more than once, what does that mean? Not a function. What if no matter where I draw the vertical line, it only hits one time? Then it is a function. All right, so that's called vertical line test. If any vertical line crosses a graph more than once, the graph is not a function. All right, so that should make part C pretty easy. Is part C a function?
No.
No, why not?
Because it crosses more than one.
Because I can draw a vertical line that'll hit that graph more than once. I could draw a vertical line right there. How many times does that vertical line hit that circle? Twice. So what does that tell me? So our answer would be not a function. And we would say we used the vertical line test, which you are allowed to be lazy and abbreviate that VLT. You do not have to write out all the words vertical line test. You can abbreviate it VLT.
So when it says to explain, that's an acceptable answer?
That would be the answer I'm looking for. Not a function because of the vertical line test. That's all I would want. How about D? Function, yes or no? No, why not?
It is touching it the whole time, or it's also if you draw it like anywhere else, then it wouldn't be touching at all.
Two very good answers. Two very good answers. One is, if I draw my vertical line right here, how many times does that vertical line hit the graph?
Continuously.
Every time, doesn't it? Or another excellent answer is, I could draw a vertical line over here, and when does it touch? Never. Why would that make it not a function?
Because it would have to increase, or
Just hit it
no,
on
because it'd be, the zero would be constant
Has to have one
for
output.
the,
There's an X number right here, isn't there? If there's an X number, I'm supposed to have a output. I'm supposed to hit the graph. Do I hit the graph at all? No. But our answer generally here would be no. And again, my explanation would be vertical line test. I drew a vertical line that hit more than once. Questions on that?
Right, now you said if you draw a vertical line on the negative side, on the left side, and it doesn't hit nothing, what is that?
Still not a function.
It's not a function, but, like, so every time we draw a vertical line and if it doesn't hit nothing, then it's...
Yep. All right, flipping the page. Use the graph of the function to determine the function's domain and range. All right, so there's some new words there, domain and range. Anybody even know what domain means?
Where it lives?
Where it lives, that's kind of true. Can you be more specific?
Quadrant?
No, not the quadrant.
You said no.
Domain is a fancy word for the inputs, which is a fancy word for
X.
X values. So when I ask you for the domain, I want you to look at this graph and tell me all the X values that are used.
-2, 0, and 3.
-2, 0, and 3. That's partially correct.
The 0, I'm guessing.
No, 0 is correct.
-1,
Yeah.
0, 1, 2, 3.
-2, -1, 0, 1, 2, 3. That's closer. All of them in between. If I told you to find what X equals a half, if X equals a half, is there a Y value for that?
Oh, okay.
Yeah, there is, isn't there? If I told you X equals -1.7, if I went over to X equals -1.7, would I hit a Y value? Yeah, I would. So my domain, when we say domain, we don't just mean the nice numbers. We don't just mean -2, -1, 0, 1, and 2. We mean all the X values, all the fractions, all the decimals, all those ugly little things. So for domain, we would write -2 less than or equal to X less than or equal to 3 for that one. Yep. Here you go. There's domain. All the X values that we use. Well, if domain is the inputs, if domain is the X values, what do you suppose range means? The outputs or the Y values. So again, looking at graph A, what Y numbers do we use? It goes from a low of -2 to a high of 4. So range, -2 less than or equal to Y, less than or equal to 4.
You always start with the lower number?
Yes. When we write our answers, we always put the smallest number on the left and the biggest number on the right, just like you would when you draw a number line. All right, so how about B? What's the domain?
-4 is greater than or equal to X greater than or equal to 5?
Right, domain means the X values. So for the X values, you go to the furthest left point, that's -4, and then you go to the point furthest to the right. What's the point furthest to the right?
5.
5. So we would have -4 less than or equal to X less than or equal to 5. So for domain, you're going left to right. For range, you're going bottom to top. All right, so what's my range?
-4 lesser or equal to Y lesser or equal to 4.
Close. You said -4. I think you mean -3.
Oh, yeah.
You want the y value there. But you had the right idea. You go from the lowest point, here's the lowest point, y equals -3, and the highest point on the graph, right there. And right there, y is 4. So our range would be, low point was y is -3, high point is 4. Okay, how about C? -3 to 5. Furthest left is x equals -3. Furthest right is x equals 5. I agree. -3 less than or equal to x less than or equal to 5. How about the range? 0 to 4. Yeah. So you do need to be careful. When we use domain and range, we don't always use the points that are labeled, do we? For domain we did, but for range, we're looking at our lowest y number. Our lowest y value is right here, and that's 0. And then we go to our highest y value, which is right there, and that's 4. So be careful of that. People think you should always use the points that are labeled. Well, not always, because sometimes the points that are labeled don't give you the high points and the low points. So you got to look for your low point. Here was our low point. Y equals 0 was right there. And our highest point was right there, had y equals 4. D. What's the domain? -3 to 3. So x is in between -3 and +3. Range? How low to how high? Lowest spot is 0. Highest spot is 3. Questions on that one?
Can you move that over to say, thank you.
How's that? Sneak in as much as I can there. All right, E is a little different. What's different about E?
We have indefinites.
We have indefinites. What do you mean by indefinites?
So lines keep going.
Well, there's no lines, are there?
No.
The curves, they're curves. What do you mean they keep going?
Because they have arrows instead of.
They have arrows, that's right. So this means this graph keeps going up and left forever. And on this side, it keeps going up and right forever, doesn't it? So what's the domain?
Infinite.
You're on the right track, but that's not the right word.
Undefined.
No, it's definitely not undefined. I mean, for example, I can use x equals 0, x equals 1, x equals 2, x equals... Huh?
Repeating?
No, x's can never repeat. How far to the right does it go?
Whatever.
It goes forever. It goes all the way to... How far is forever? Infinity. That's right.
It's not infinite.
But how far to the left does it go? Not infinity.
Negative.
Negative infinity.
Oh.
So our domain is... We can go forever to the left, which means we can go as far left as negative infinity. And it goes forever to the right, so we can go as far right as positive infinity.
I was thinking the first time she used an infinity symbol during right in math.
Okay. When your domain is negative infinity to positive, in other words, I can use any number I want, can't I? I can use all the numbers. There's no restriction. We usually call this all real numbers. And when you go to do your homework on MyLab, I think for all real numbers, you have to check on this. When your answer is all real numbers, I think it just has you give a capital R. So instead of writing negative infinity to less than x, less than infinity, I think you just put a capital R there. But read the directions. I'm pretty sure that that's how it works.
Could we just rate all real numbers? Would you accept that?
I will accept it on a test, but if you type in all real numbers into the box on MyLab, it will mark it wrong, of course. So watch the directions. It'll tell you what to do. I'm pretty sure if the answer is all real numbers, you just type an R. How about the range? The lowest y value is 1. Happens twice, but that's okay. What's the biggest y value?
One's negative, one's positive, doesn't matter which one you use.
Well, one x number is positive and one x number is negative, but they both have y equals positive 1. So our lowest value is 1. What's our biggest value?
Infinity.
It goes up forever, doesn't it? So how do you write that?
2 less than or equal to.
Not 2, 1. Or y. This is y values, so this is 1.
Right. No, but greater than or equal to 1 y. Greater than or less than or equal to infinity.
All right, so we could write our range. Oh, don't confuse this R with that R. I'm going to make this R different, just so it looks different. That's the R for all real numbers. This is R for range. We could write it two different ways. Typically, we would just write it as y starts at 2 and it gets bigger. So we could just write it as y greater than or equal to 2. You could write it using the infinity symbol, and then it would look this way.
Doesn't it
Yeah,
go
it's
down
1.
to
I got
1 though?
confused, man.
It would look that way.
Doesn't it go down to 1 though instead of 2?
Yeah.
Oh, yeah, let's go to 1. Sorry.
So basically 0, 0 would be, is the number, the never ending.
No, that's the infinity symbol, not 0, 0.
Why am I thinking that 0, 0?
That's supposed to be infinity. Okay. So typically, I would write it this way: range y greater than or equal to 1. But if you want to write it the same format that we wrote all the other ones, you would write it that way. Okay, good.
Is the top one what my math lab would probably accept?
I think that's what my math lab wants, is y greater than or equal to 1. And how about the last one?
I go with all the numbers.
Domain is all real numbers. Why is domain all real numbers?
Both directions, correct?
Because we have an arrow on this right-hand side and we have an arrow on this left-hand side, which means it keeps going up and right forever, it keeps going down and left forever. And how about the range? Same thing, all real numbers. Why?
Infinite.
Infinite, because it goes up
0, 0.
forever and it goes down forever, so we can get any y values. So our answers for both of those should just be all real numbers, all real numbers.
So far, everything that we've been doing here in class, you've been setting up for something else.
Yes.
So it's going to get, we're going to be going on with this principle or whatever the hell this is right here? Part of
Yes.
language. Okay. Great.
So in this big packet I just gave you, I don't know how many sheets are there, like 5? A lot of sheets here. We're going to be graphing different kinds of equations. They're all going to be functions. Some of these equations are going to be lines, but some of them are not. What can you tell me about that first one?
Y is 0.
It's a line.
That one's definitely a line. And how do you look at that one right away and you tell me that one's a line?
Because all the x numbers are going up by 1, and then all you got to do is just multiply by 3x.
Okay, so a good answer would be, this is in the form y equals mx plus b, where in this case, what's our b number? 0. There's no number written out here, is there? There's no number, so our b number is 0, which tells us our y-intercept is 0, 0, and our slope is 3 over 1. 3 over 1. So we know how to draw this one quickly, don't we? Our intercept we decided was 0, 0. 0, comma 0. Up 3 over 1. Up 3 over 1. Let's see, let's label those points. This one is the point. Not 3, 1.
1, 3.
It's 1, 3. Our slope, we go up 3 over 1, but then the point is kind of backward, isn't it? The point is, we start at the origin, it's 1, 3. And the other point is 2, 6. I didn't draw it very straight, but you get the idea. How about number 2?
So now we have the slope.
Well, it'd be,
What?
you could plug in 0, 0 first,
If x is 0, y is 0. That's certainly true.
and then you could go down to over 7 from 0 to
So you're telling me this is a line again.
yeah.
And how do you know it's a line again?
What is that for?
It's in the form y equals mx plus b. B is 0 again, and m is negative 2/7. What if I was in a bad mood and I told you you're not allowed to use the slope, you got to plug in some numbers?
Using my multiple of 7.
You would definitely want to use multiples of 7. Why would you want to use multiples of 7? To make those fractions go away. So for example, you might plug in 7. What's negative 2 over 7 times 7? Could you think of that 7 as 7 over 1? They cancel out, you get negative 2. And what's another good number you might plug in?
Negative 7.
Negative 7 would be a very good number. What's negative 2 over 7 times negative 7 over 1?
Positive 2.
Positive 2. And that's enough numbers, I think. But if I was really, really mean and said you got to plug in 2 more numbers, 14 and negative 14. And why would you use 14 again? Because 14 divided by 7 is a nice thing. It's 2. All right. So we have 0, 0. That's right there. We have 7, negative 2. 1, 2, 3, 4, 5, 6, 7. 1, 2. 7, negative 2. And negative 7. 1, 2, 3, 4, 5, 6, 7. Positive 2 right there. And we could draw a nice straight line. So nothing new so far, right? What can you tell me about problem 3? Still a line. I'm going to skip problem 3. You're going to go home and you're going to do that for homework. What can you tell me about problem 4?
Line.
It's a line. I'm going to skip number 4. You're going to go home and do it for homework. That's correct. Number 5. Not a line. How do you recognize, just by looking at that right away, how do you look at that and you say, not a line?
It's not MX plus B.
It's not an mx plus b. Why not?
It's M over X.
Because that x is down on bottom. To be a line, you're not allowed to have x down on bottom. So when we graph this thing, immediately we know we better not get a line. Correct? All right, so it says, I didn't leave any space here really. Go to table. Use negative 3, negative 2, negative 1, negative 2/3. Oh, look at all those points it tells us to use. All right, so I'm going to build a big table here. X and Y. Negative 3, negative 2, negative 1, negative 2/3, negative 1/2, negative 1/3, 0, 1/3, 1/2, 2/3, 1, 2, and 3. Boy, it's making us do a whole lot of points, isn't it? Why do you think it's making us do a whole lot of points?
Whole lot of curving.
Because there's a whole lot of curving. We need to do a lot of points to find out what it's going to look like. 2 or 3 points isn't going to be enough. Why not?
2 or 3 points might end up being a line.
2 or 3 points might end up looking like a line, and we know for a fact that this is not a line. We know that for a fact. All right. Well, let's start with the positive numbers. Those seem easier. So I'm going to start way down at the bottom, and I'm going to plug in x equals 3. If I go here and I plug in x equals 3, what do I get? 1/3, I get a fraction, okay. Not too bad so far. Plug in x equals 2. 1/2. Plug in x equals 1. 1 over 1 is 1. Alright, now it gets ugly. Plug in 2/3. What's 1 divided by 2/3?
2/3.
No. That would be 2/3 divided by 1.
Oh, the 1.5.
1.5. How'd you get that?
I just took reciprocals and
If I want to take the number 1 and divide it by 2/3, how do I take a number like 1 and divide it by a fraction?
Divided by the 2/3 underneath. Or multiply.
Multiply by the reciprocal. So this is 1 times 3/2. 1 times 3/2 is 3/2. All right, so some more fractions. What about when I plug in 1/2? What's 1 divided by a half? 2, because 1 divided by a half, I would leave the 1 alone, and I would flip and multiply. So I would have 1 times 2 over 1. 1 times 2 over 1 is 2. All right, well, moving on. Plug in a third. 3, because 1 over 1/3. Again, I would flip and multiply. That's 3. Plug in 0.
0.
Nope. Not 1.
It's got
It's undefined. Why is it undefined?
zeros
Divided by
underneath.
0.
Because it's 0 underneath. Can you have 0 on bottom? When can you have 0 on bottom? Never. So we have 0 on bottom. We have undefined there. What are we going to do with that? I don't know. Some question marks there. Seems weird. All right, now we plug in the negative numbers.
Same thing reverse.
You're going to get exactly the same answers, except they're all going to be negative. All right. Well, you guys are clever there. Negative 1/3, negative 1/2. I'm starting at the top. Negative 1, negative 3/2, negative 2, and negative 3. So I don't need to do all that work again, do I? I can just say, it's the same thing, just minus signs. Okay, let's try to graph that.
Can you go back up?
can we make our scaling a third? Well, it's still without, but a half.
Well, we're going to estimate a little bit here. We'll do okay. So we're still going to go.
You can't see it.
I know. I'll put it back here in a minute. Oh, you can't see this. I'm going to go maybe. I only have to go as big as 3, don't I? So I'm going to go. 1, 2, 3, 4. I think we could go by 1/3. So I'm going to go. 3 dots is 1. So this is 1/3, 2/3, 1, 2, 3. I think I'm going to have each little tick mark be a 1/3. Negative 1, negative 2, negative 3. And then same thing here. 1, 2, 1, 2, 3. And negative 1, negative 2, negative 3. Okay, so I have negative 3, positive 1/3. I'm sorry, negative 3, negative 1/3. So where's negative 3, negative 1/3? Well, here's negative 3, and then negative 1/3 is just one tick mark down, aren't they? Because my tick marks are all 1/3. Negative 2, negative 1/2. Where's negative 1/2?
Half in between. A third.
Halfway in between, so it's right there. There's negative 2, negative 1/2. Negative 1, negative 1. negative 2/3, 1, 2, negative 1.5, negative 3/2, that's right there. Negative 1/2, negative 2. Let's see, there's negative 1/2, negative 2. And finally, negative 1/3, negative 3. Does it look like a line? No, but that's a good thing. Why is that a good thing? It wasn't supposed to be a line. What do we do? Connect the dots with a nice smooth curve. Now I have a question for you. When I connect this, is it going to jump and come over here somewhere? No, why not?
It's just going to repeat. Well,
It's going straight.
it's going like a ray over on the other side.
Yeah. Can this graph come down and hit this axis at all? No, why not?
Jut straight across.
Because that's when x is 0. Why? So can I plug x in? No, which means I can't hit this line. And I don't think I can hit y either. How come I can't hit y? Well, no matter what number I plug in for x, pick any number in the world you want for x, are you ever going to get an answer of 0? No, you're always going to have 1 over something. It's going to be something, isn't it? It's never going to be 0. Could it be really, really small and really, really close to 0? Yeah, like if I were to plug in 100, that would be 1 over 100. That's pretty close to 0. If I were to plug in 1,000,000, 1 over 1,000,000, that would be really close to 0. So I think what has to happen is it gets really close to the axes, curves like so, but it doesn't touch either of the axes. I think it has to look like that. So that was for all my x being negative numbers. What's going to happen when my x is positive numbers?
It'll invert.
It's going to invert because we've got all these same x's and y's, don't we? So it's going to have another chunk up in the first quadrant here that does the same thing. It's going to have the exact same shape. Okay, so that's kind of a weird function. It looks like that. Questions on that one?